Okay, so last section we're going to take a look at is 7.4. And this is basically on solving equations, either logarithmic equations or exponential equations. And it's going to use all the properties that we've learned. Okay, how to change between log and exponential form, maybe change a base formula, and some techniques from algebra. Like distributive property might come up, factoring could come up, quadratic equation, things like that. All right, so let's pretty much start off with an example. All right, so first example says to solve 2 log base 5x equals log base 5 of 9. So the fact that the bases are the same, that's good. Okay, if the bases weren't the same, that would be a problem. All right. Does anybody see something that we can do on one side of that equation using a rule we learned yesterday? Jacob?
You move the 2 to be like an exponent over the x.
Yeah, let's put the 2 back as an exponent, even if we're not sure what that's going to do at this point. I mean, I don't know what else we're really going to try. So let's try putting the 2 back as an exponent. So we have log base 5 of x squared equals log base 5 of 9. So x squared is my argument on the left. 9 is my argument on the right. The log base 5, the part that I just underlined in red, that already matches on each side. And that's the goal here. Equals mean you have to have the same thing on the left and on the right. So we need to find a number for x we could fill in, and it would make the argument on the left a 9, just like the argument on the right. So what could I plug in for x to make that happen? Right? 3. 3. X would be 3. And if you're not sure how to get 3, well, the idea here is the log base 5s already match, so we can ignore those. Let's look at the part that doesn't match. We have an x squared on the left, and we want that to match the argument on the right, which is a 9. And if you want to solve that, you take the square root of both sides. And you get x equals 3. And that's how you would solve it. Any questions on that one? All right, let's try another one like that. Let's do log base 3 of 2x plus 4 equals log base 3 of 3x. Actually, you know what? Let's do 4x minus 5. So what already matches here? The base, right? The log base 3 matches the log base 3. So we don't have to worry about that. What we need to match is that and that. So how could I write that down? Kind of like I did on the last problem, kind of over on the side. I'm looking for what I would write that looks like that for this problem. What would I write down, Dominic?
2x plus 3
Yeah. The log base 3 is already matched, so all I have to do is figure out how do I make the parts in green match. I need 2x plus 4 to come out exactly the same as 4x minus 5. So set them equal, and now solve. James, what would be my first step to solve that?
It'd be to put the 4 on the other side. Like, isolate the
Variable.
Okay, and I would probably leave the 4 where it is, because if we move the 4, we're going to have to deal with negative numbers, but if we leave the 4 where it is,
I'll move the 5.
I would move the 5. And how would you move that?
Add 5 to both sides.
Okay, so we add 5 to both sides, that's gone. So now we have 2x plus 9 equals 4x. All right, and what would I do next? Yep, okay.
Subtract 2x from both sides.
Yep, I would subtract 2x. So that's gone. So now we have 9 equals, and Jane, what's 4 minus 2x?
2x.
2x. And Colby, what would be my last step?
Divide both sides by 2.
Yeah, divide both sides by 2. Divide by 2. Divide by 2. So if you leave your answer as a fraction, it's 9/2. Or if it's decimal, it would be 4.5. And that's easy enough to check. If you plug 4.5 in, you could check it and see what we get. So let's try it. Let's move that. So if we do 4.5 times 2 plus 4, I get 13 on the left. So my hope is I get 13 on the right. Let's see. 4.5 times 4 minus 5. Perfect. So if I plug 4.5 in, I get 13 on both sides, and that would make them match. Any questions on that type? All right, that's where the bases already match, and we just have to make the arguments match. All right, so we got that one. Let's try this one. A little bit different setup because this time we have logs with the same base, which again, that's good, but they're on the same side. And there's something we can do with everything that I just put that box under. We have 2 separate logs with the same base. What did we learn yesterday that you can do if you have 2 logs that are separate and they have the same base? You can take them and do what? Yep. We can combine them. So let's combine these into a single logarithm and see what happens. How about Lacey, when I combine them, what's going to be the base? How'd you get 8?
Or would it stay 4?
Yeah, it's going to stay 4.
Okay.
Okay, when you combine or separate logs, the base never changes. All right. And inside here, I need to put my argument to the log function. Well, the original arguments were x plus 3 and 2 minus x. How am I going to recombine those into one argument? What math operation are we going to use? Yeah.
Would we 4 of them?
Yeah, we're gonna multiply them because we have addition. Addition means originally they were multiplied, and because these are 2 sets of parentheses, we have to FOIL them. Exactly. So we have x plus 3 times 2 minus x. Let's do that out. Okay, that would be the next thing you want to do. If you have something you can do out, that's multiplication or division, do it out. And then see where you're at after you do that out. So log base 4, it's going to stay right where it is. And let's FOIL it. Okay, so Cassidy, what is x times 2?
2x.
2x. I'm going to write this off to the side, just like kind of like my work on the side, and then I'll put the final answer in parentheses. So I've got 2x. And then, Autumn, what's x times negative x?
Negative x squared.
Negative x squared. And Jess, the inner, 2 times 3?
6.
6. And the last, 3 times negative x. And Katrina, what's that?
-4.
Good, negative 3x. Okay, so we've got some like terms that we can combine. Let's write down what we know isn't going to change. Negative x squared. Nothing I can combine with that. Plus 6. And be able to keep that. But we have 2x minus 3x. And Johnny, what's 2x minus 3x?
-x.
Negative x. Good. Okay, so we had 2 logs, we combined them all into one, and now we have an equation in log form. That's as simple as it can get in log form. So what else could we try to do from here? And this is one of the, actually it is the first thing I taught you, what you can do with a log equation. Yep. Change it to exponential. There's nothing else to combine, so let's try changing it to exponential, and that will get rid of the word log. So here's your 3 things. 1, all of that is 2, and that's the 3rd thing. So let's start with the 4. Ava, what's the 4?
The base.
The base. Okay. Where is the base? And then, Vivian, logarithm always equals what kind of number?
Exponent.
The exponent. So the 1 is going to become an exponent. And Dominic, the box in green, what do we call that?
That's the argument.
That's the argument, and it ends up separated from everybody else on the other side. So negative x squared minus x plus 6. Okay, from this point forward, solving that is algebra 1. It's not something we specifically covered in this class. The trig part of what I had to show you is done. Okay, the log is out of the problem. So, what could I do out next here? Just quick thing. Yep.
4 to the first.
Yeah, we might as well do 4 to the first. That might not always be to the first, but whatever it is, let's do it out. And what is 4 to the first? 4? Now, anybody remember when you have an equation with a highest exponent of 2, what type of equation that is? Ends with a Q. Yeah?
Quadratic.
That's a quadratic. Generally, when you solve a quadratic equation, 2 approaches you can take are you can try to factor it, or you can use quadratic formula. I always try factoring before quadratic formula because if it works, it's faster. But when you factor, you don't ever want x squared to be a negative. Okay, so we'll have to fix that. The other thing is, when you're setting something up to factor, you don't want it equal to 4. There is a number you want on this side, but it's not 4. Does anybody remember what number you always want to get a quadratic equal to? Yep. 0. Always want to get it equal to 0. So let's do that first. Let's take the 4 and put it on the other side. And Olivia, how would I move the 4 to the other side? If it was multiplied by something, we would divide it. We would minus. Okay, we're going to minus 4. Minus 4. Now you don't have anything on the left side. That's exactly the way you want it when you're solving a quadratic. Everything else, in terms of the negative x squared and the negative x, stays the same. And then 8 and 6 minus 4.
2.
You get 2. Okay. So it's a little bit better. You got it equal to 0. But I still don't like that I have a negative in front of the x squared. I don't care if I have a negative anywhere else. I just don't want it there. So what could I do on both sides? to get rid of the negative in front of the x squared. It's going to change some other things too, but that's fine. I just don't want it with the negative. Bless you.
Thank you.
Just no negative with the x squared.
Divide by -1.
Yep, you can divide everything by -1. And what that's going to do is just change the sign of everything, but most importantly, it's going to change the sign of the x squared and make it positive. Okay, so 0 divided by -1, still 0. And then everything else, the sign will change. X squared plus x minus 2. Okay, and I think that that problem is going to be factorable. So let's try it. Does anyone remember what's the first thing you write down when you're going to set up a factoring problem? It's not even numbers, just some symbols. Yep.
2 sets of parentheses.
2 sets of parentheses. First thing you want to figure out is what goes in the first spot in each parenthesis. And they have to multiply together to give you x squared. Yep.
X.
Yep. And
X.
x. Good. X and x. Next thing we have to do is figure out the signs here. Positives and negatives. The choices are either both positive, both negative, or one of each. If you look at these two signs up above, it tells you what to use down below. Does anybody remember what the signs would have to be in this case? Yep.
Negative and positive.
Yep, you will need one of each because you're going to have numbers here, and they have to multiply together to give you a -2. The only way you can multiply two things and get a negative is if one is negative and one is positive. Okay, now I need two numbers that multiply to give me 2. What are two numbers that multiply to give me 2? Yep.
1 and 2.
1 and 2, and it does make a difference which one we put where. Do you want to do 1 and 2 or 2 and 1?
1 and 2.
I like 2 and 1. That's a great idea. Let's go with that. And at this point, when you check it, you would know whether or not you should have done the 1 and the 2 or the 2 and the 1. But let's check it and see what happens. X times x is x squared. What's x times -1?
Negative X.
What's x times 2?
2X.
2x. What's -1x plus 2x?
1X.
1x. And that's exactly what we want. If those numbers were switched, we would have gotten -x instead of +x. But we wanted +x. Okay, so it would be an easy fix. We just switch the numbers. All right, and that's the hard part, okay, the factoring. Now, we have something times something, and it has to equal 0. How can you multiply two things together and get 0? Something very specific has to happen. Yep.
One of them has to be 0.
Yeah, at least one of them has to be 0. So figure out what would make each one of those things in parentheses 0. So let's set the first thing in parentheses equal to 0, and that'll tell us what you'd have to plug in. And set the second thing in parentheses equal to 0. All right. So, Angelina, what number would I have to plug in to for x right here to get 0? Yep, so we minus the 2, and we get -2. And what number would make my second factor 0? Yep, 1. So those are the two potential answers. We have to always make sure that we're never taking the log of a negative number. Remember, we talked about logs of negative numbers, and those are imaginary. We're not dealing with imaginary logs. So we have two numbers as potential answers. Let's scroll up plug them in to the original problem and make sure that we never have the log of a negative number. Let's check 1 first. So if we plug in 1, what's 1 plus 3? 4? Is that negative? Nope. Okay. What's 2 minus 1? Vivian? 1. Is that negative? No. So if you plug in 1 here, you don't get a negative. If you plug in 1 here, you don't get a negative. 1 works. Okay. So this one's good. Let's check negative 2. What's negative 2 plus 3? Yep. Is that negative? Okay, we're fine there. Bless you. Let's plug negative 2 in here. 2 minus 2. What's that? Yep. Is that negative? No, then we're fine. Both of those answers work. They are both answers to this problem. When you solve a problem that involves factoring, there's 3 cases. Case 1, both answers work. Case 2, one answer works, one answer doesn't. Case 3, they both don't work. Okay, so if they both don't work, there's a symbol that sometimes we use in math that represents no solution. Anyone ever seen this symbol? This symbol means that there is no solution. This problem has solutions, negative 2 and 1. That's why I circle them. Those are the answers. But if you have no solution, you can use this symbol. Anybody know what alphabet it's from? Yeah. Well, actually, yeah. Go ahead.
Is it Swedish? It's Scandinavian.
Yeah, it's Scandinavian. It's when I went to Norway, I did see that letter used in their alphabet. So I don't exactly know the alphabet. I don't know if you call it the Norwegian alphabet, or Scandinavian alphabet, but it's a Scandinavian letter. Yeah. All right. So that's a symbol you can use if there's no solution. I don't know why we use that symbol, but that's what we use. Okay, so any questions on that? So very little in this problem is stuff that I had to teach you this week. Only thing that I taught you is combining 2 logarithms together and changing to exponential form. FOILing is something you would have learned before this class. Getting a variable by itself, factoring, solving equations, that's all stuff that you would have done, But that's about as complicated as a problem you would have. So if you can do that one, and you understand what we did, then you won't have anything more complicated than that on the test. All right, let's see. All right, let's try this one. It's going to be a lot easier than the last one. Do we have multiple logarithms to combine together here? Think, Jody? No. There are no multiple logs to combine together. Are there any numbers in front that we have to put back as exponents? No. So there's not really much else we can try except take this equation and do what? Yep.
Make it exponential.
Make it exponential. Get rid of the word log. All right, so how about, Ben, what's my base?
3.
3? Jaden, what's my exponent?
9.
Logarithm always equals the exponent. And Dominic, what's going to go on the other side? X. Oh, there you go. There's your answer. If they wanted you to do that out, you could type it in. If it If the answer starts to get really big, I'm just gonna have you leave it like that. Like if the answer was in the billions or something, we'd just leave it like that. Let's see how big that is. That's not really that big. So that one I'd probably ask you to write it out. I mean, it's big, but it's not, it's not huge. 19,683. Okay, any questions on that one? All right. Let's try this one. It says 2 to what power would give you 5? Now, if the number on this side was an 8, now that would be a lot easier. If it was a 16, basically if it was a power of 2, we could do it in our head. But we can't because it's a 5. So, what type of equation is that? Is that a log equation or exponential? Pete?
It was exponential.
Yep, that's exponential. Well, there's only one thing we know to try with an exponential equation, and that's change it to, let's try changing it to a log. Okay, if it's already a log, we usually try changing it to an exponential. If it's already an exponential, we try changing to a log. All right, Raymond, if I want to change that to a log, what's the first thing I would write down? Log. So we've got log. James, logarithm always equals what kind of number?
The exponent.
The exponent, which in this case it is
X.
x. So that's nice. We already have the variable by itself. Colby, what's going to be the base on my log?
5 or 2.
Which one?
2.
Yes. 2 is lower than the x. It's the base on the exponential. It stays as the base when we write it as a log. And Jacob, what about my argument? That's the 5. Okay, so that's the answer. Log base 2 of 5. Can I do base 2 on the calculator by pressing a single button? No, there is not a button for base 2. So how am I going to get that rewritten so I can type it in? Vivian?
You're gonna do log 5 over log 2.
Log 5 over log 2. Perfect. Anybody remember the other way you can type it? Yeah?
ln 5 over ln 2.
You could do ln 5 over ln 2. Same thing. Make sure when you type it in, close the parenthesis to let it know you're done with the first log. So it should look just like that. And the answer is 2.322. If we go to 3 decimal places. 2.322. Okay, any question on that one? Well, this one's pretty much the same thing. 3 to the x equals 24. Anyone think they can tell me the whole equation I would set up to solve that? It's going to be just like the last one, except instead of a 2 and a 5, I have a 3 and a 24. It's exactly the same setup. James?
X equals log base 324.
Perfect. Log base 3 of 24. And we'll type it in the same way. Log of the argument, divide by log of the base. In this case, 2.893. Make sure you do round properly. Okay. And if you have time, that's easy enough to check. Just take and plug it in. Type in 3 to the 2.893 power on your calculator and see if you get 24. If you do, then you get it right. Okay. Questions on that one? All right. Okay, this one's kind of the same as the last one, except it does have one extra step. You want it to look like this. And that's what the last two problems look like. What would you have to do first here to get the 3 to the x by itself? Ready?
You would divide 8 on both sides.
Yeah, you just have to divide each side by 8. Now, it's exactly the same as the last problem. But instead of a 3 and a 24, now you have a 3 and a 5/8. Okay, same thing. And I'll just finish it off. I'm not going to type it in this time. I'll just write out how you would do it. You have to use a log. The base would be 3, and the argument is 5/8. Any questions on that? We're gonna hold off on that one. And let's look at this one. So this one, I just want to make sure we're careful about something. You might think that example 8 is very similar to example, where was it? Example 2. You might think that example 8 looks very similar in setup to example 2. But what's different about example 8 that really messes everything up? And that's really all I want to point out in this problem. We're not going to finish it. Yep?
The bases are different.
The bases are different. So you can't solve this by writing it with a common base because the bases can't be combined. Okay? And that's all I want to make sure you notice in that problem. So this looks like example 2, but the bases are different. Because the bases are different, we can't combine this the way we did before. Okay, so this looks like example 2, but the bases are different. The two logs cannot be combined. And that's what I wanted to make sure that you noticed. Is it still solvable? Oh yeah, we can definitely still solve it. But it's just not something we're going to focus on. Questions why you can't combine the logs together? Yes?
Do you think you could like briefly cover how you would be able to solve it?
I'll show you the first step. So you have to rewrite it like this. Log x over log 3, that's just using the change of base formula, plus log x over log 4. That would be the first step. Now, everything there, base 10, base 10, base 10, base 10. Now everything has the same log base. But that would be the first step.
Okay.
Yep. Right, and let's look at this equation. X plus e to the x equals 2. Now, remember, e is not a letter. E is the number 2.718. X plus e to the x equals 2. Remember, the goal when you want to solve a problem is to get x by itself. Well, if this x wasn't here, well, that'd be easy. All I'd have to do is minus e, and there's the answer. 2 minus e. That would be 2 minus 2.718. But that's not the problem. if this x wasn't here, well, that would be easy as well too, because I only have one variable, and now you could think of this and rewrite it in log form. Log e is the base, logarithm always equals the exponent, and the argument is what was by itself. So that would just be the ln of 2. Very easy. The problem I have is it's x plus e to the x. I have this x in both spots. And there is no way that I know of to get the x by itself. You can't do it with algebra. So one thing we could do, and here I just want you to understand that there are other ways to solve equations besides using algebra, is I could do something like this. I could type in x plus e to the x. Okay, I put what was on the left side in one line, and I'm going to put a 2 on the other line. So what's going to happen here is the calculator is going to draw a picture of this, and it's going to draw a picture of that. Okay? Let me show you what the two pictures look like. So that's the left-hand side. The other one is a lot simpler. The 2, that's just a horizontal line at 2. Then you want to have a guess where the answer would be. Angie?
Where they meet.
Yeah. The answer is where this equals this. So when I look at it as a picture, what does it mean where two pictures are equal? Well, it's where the two pictures meet or where they cross. And a calculator like this can automatically calculate for me where the two graphs intersect. All I have to do is press that button, hit enter, and it tells me the answer is 0.44, I don't know if you can read it or not, 0.4428544. Okay, it gives me the answer. Again, the point to this one is just to show you some equations cannot be done algebraically, and we have to do some other methods. This is more of a graphical method. Not something we really spend a lot of time on, but something I wanted to just show you on the calculator. Okay. So that one cannot really be done by hand. Any questions on that? Okay. So that is the last homework assignment for this week, page 490. 1 through 3 all, 5, 6, 9, and 17 to 21 odd. Okay, so those are the topics that will be on the test tomorrow. So remember, we will go over the homework. We'll start the test on Thursday. I'm thinking you'll have enough time to finish it, but if you don't, then you'll have a little bit more time on Friday, and that should say combining, not confining.